Review some pre-cal. Now the first thing I'm going to review is solving inequalities. You may remember this from Algebra 2 in your pre-cal class. They are very easy to do. So this is a problem that's taken from your summer packet, and we want to find out where this polynomial is less than 0. And we're really talking about a number line. Now the first thing we're going to find are our critical numbers. That's where the value of x is actually equal to 0, and that's easy to do. We get x equals 2. We get -1, and we get x equals 5. And I'm going to draw all of those out on a number line. Go in order, -1, 2, and 5. And the number line is going to help me do what we call a sign test. This is really big in calculus, so you're going to be doing this so much by the end of the year, it'll be crazy. And now what we're going to do is we're going to pick numbers in each little domain area. Like I want to pick a number less than -1. I may pick -7. Just go crazy. So if I plug in -7 into each one of these terms, I get -7 minus 2, which is negative, but I'm squaring it. You square a negative, you still get a positive. -7 plus 1, also going to be negative, but I'm cubing it. So negative cubed is going to be negative. -7 minus 5 is also negative as well. And I take a look. I get a positive, a negative, and a negative. Well, two negatives make a positive, so this region right here is going to be positive. Now I pick a number between -1 and 2. Easy. X is 0. I do the same thing. That's always going to be positive. That's going to be positive. And this is going to be, at 0 minus 5, negative. 2 positive and a negative makes a negative. Pick a number between 2 and 5. I may pick 4. 4 minus 2, positive, positive. Now, be careful. 4 minus 5 is negative again. So again, this is a negative little area right here. And now I want to pick something bigger than 5. I may go crazy and pick 10. So if I pick 10, let's take a look here. This is still going to be positive. Positive. Now 10 minus 5 is positive. All three are positive. That's a positive region. Now, how do we get our answer? Well, we're looking at this. We're less than or equal to 0. That defines to be negative numbers. So we're looking for anywhere where that is a negative. And that's here and here, where the negatives occur. Now, the next question we have to ask, can we include the numbers themselves? And yes, because it's equal to. So I'm going to make those little solids. And when I write my answer, of course, this is going to go from -1 to 2. And you can write it this way, or 2 to 5. And that's okay to write it. But if you notice, that kind of repeats itself, so it's a better way to write it this way, just from -1 to 5. And that's how we should write it. That's what I'm looking for right there. So let's take a look at another example here. Okay, let's take a look at another example. Let's try this one. X squared minus x minus 12. And I'll show you an easy way to sometimes do these. Again, I'm looking for what's greater than 0. So this one's not factored, so I'm going to factor that first. X minus 4, x plus 3, greater than 0. Find my critical numbers. We get 4, and we get -3. So when I draw my number line, here we are. Here's -3, here's 4. This time I want greater than 0, so I'm looking for the positives. Now, there's an easy way to do this one. This is a parabola. We know what parabolas look like. We can't include here because it's not equal to. It's just I'm going to leave those open. But this is a parabola, and it's a happy parabola. It opens up. And this is, remember, this is really the x-axis. The number line is really the x-axis. So that's where it crosses the x-axis at. And there's our graph. Now, where is it positive? Where it's above. Positive, positive, and it's negative in the middle. So if I want to write this, where is it positive, to get my answer, I'm looking for anything to the left of -3 and everything to the right of +4. So it's going to go from -infinity to -3, both soft brackets because you can't include either one, or 4 to infinity. And again, both soft brackets. Very easy to do. And don't forget, you can even do this with rational functions. Okay, so let's take a look at this example. 3x minus 2 over x plus 4 is less than or equal to 0. Same idea. You just want this to be less than or equal to 0. So what you're going to do is you're going to look at the top and you're going to look at the bottom. Later on, we'll talk about why we do it this way. We're really looking for where is it equal to 0 and where does it not exist. That's where we can have signs change. So we take the top, set it equal to 0, and the bottom, set it equal to 0. And I solve. X equals 2/3, x equals -4. And those are your critical numbers. And we do the same thing. Here's -4, here's 2/3. And you may be thinking, Mr. Warnow, I don't know anything between 2/3. You know one number in the middle, 0. And here are my two -5, and over here, oh, let's pick 1. Keep it simple. Plug in -5, the top's going to be negative. Plug in -5 on the bottom's negative. Two negatives make a positive. Plug in 0, the top is negative. The bottom this time is positive. A negative and a positive, negative. Plug in 1, positive, positive, positive. Very easy to do. Now the next thing we have to do is see if we can include them. Now, the top can equal 2/3. So we can have 0 on top. The problem is no 0 on bottom. You can't have 0 on bottom, ever. So this one we can't include. That has to be open. Therefore, this has to be open. All right, so when I write my answer, I want less than or equal to 0. Remember, we want it to be negative. So my answer, where it's less than 0, between -4 and 2/3. Open here because we can't be -4, and closed here because it can actually include the 2/3 right there. And there's our review of solving these. And you're going to see this on your test, so make sure you study for that, okay? Bye.